Okay, in bitwise operator we are going to the next question. So here we are going to do a swap of two numbers. So you have to basically work out with this how to swap two numbers. There are various logics available. So when you work out with numbers, when you add, when you OR, when you XOR, you have to try out different methods. Here I will be showing you one method, but before trying out this method, try on your own how to swap two numbers. You take two numbers, you do some logic with that, and then find out how we can swap these two numbers. Okay, so here I am just going to show you one of the logics. Yeah, I am going to give two numbers in the main function, int a comma b, and what I am going to do is printf enter two numbers, then you have to scanf. Always in scan, do not forget to put the ampersand sign, which I always forget actually. Ampersand a comma ampersand b, okay, semicolon. Okay, now what you have to do, you have to write a logic. So here the simple logic is I'm just going to swap it in one sentence, so that the portion goes a little bit faster. Otherwise I have to write the whole thing once again. So what I am going to do is A XOR B XOR A and A XOR B XOR B. This is the logic I am going to use. There are various other logics, so you can do it using AND and OR. First you can OR it and then AND it. A or B and A and A or B and A or B and B for the first number, A or B and A for the second number after swapping. So that is also another logic which you can try out. There are various logics available, so you can try out various methods. This is one of the method. So let's check the output. Swap bitwise swap. Okay, two numbers are 5 and 6. So 6 and 5, as you can see here, 6 and 5 will be the output. Okay, now let's go to the next question. Okay, next question is okay, you are given a number and you're given a position. You have to display the number at that position. In order to get any bit, okay, you are given a position, right? If it is a fifth position, how many times you have to shift? You have to shift 5 times, and after you shift 5 times, what happens that number at that position comes at the end. So when it comes at the end, and when you AND it with the number 1, with a bit 1, what happens is you get the bit at that particular at the end of the number. So I'll just show you in the PowerPoint so that you can understand. Okay, here I am going to show how to display the position. Suppose I have got a number like 0 1 1 0 1. So I am given a position like 3, third position. That means 1 2 3. This is the third position. So when I see, so you have to count it like 0 1 2. Okay, position I take it from 0 1 2 like that. So this is a 0th position, first position, second position. So if it is a 0th position, you need not right shift anything. If it is a first position, you have to right shift by 1. If it is the second position, you have to right shift by 2. So when you right shift by 2, what happens is these two numbers moves out, and 1011 is only remaining. 1011. Okay, now what happens is this is the bit at the second position, 0 1 2. So this is the bit at the second position, number 1. So the number 1 has come over here, and I have to I have to capture this one, right? So I am going to AND it with 1. So when I AND it with 1, what is the output? Output is going to be 0 0 0 0 0 1, right? So you get the what is the bit at that position. So the bit is at position 2, the bit is 1. Suppose the bit over here was 0, like the second position, suppose here it is 0, here it is 0, then what will be the output here? 0. Then what is the output here? 0. Okay, so either it can be 1 or it can be 0. Okay, this is how you do the position display bit at a particular position. So here what you do is do AND operation with 1. Okay, so this is what you do. This is what you do. So I hope so. Here what you have to do is you have to enter one number, enter a number and position, both you enter. So you enter the number A and position you enter at here B. Okay, now what I have to do is I have to right shift this. A is equal to A, right shift, A right shift the number of position which is given over here. So position, if I count from 0 1 2, then it is like that. If it is coming from 1 2 3, if I count like that, so here you have to shift it p minus 1 times. Okay, then what I have to do is p is equal to, you get an A, right? You right shift it and you have to AND it with 1. So this B is going to be the output. Bit given this is equal to B. Okay, yeah. Now let's check the output. This is position bitwise. So enter the number. Okay, I'll just take this number over here. What is this number? 1 8 32. Let's delete this number. Okay, this is like 8 9. So I'm taking the number 9. Position I'm taking it as 2. So it is 0. Output is 0. Suppose here I'm taking 1 over here. So 8 13. Suppose I'm taking another example, 0 1 1 0 1. Then that will be 13, number 13. Let's check with that also. 13 position 2. So the bit at the given position is 1. So this is a mentioning a position and getting that particular bit at that position. Okay. Similarly, another question is like to find whether the number is odd or even. If the last bit is 1, it is going to be odd number. If the last bit is 0, it is going to be an even number. How do you check that? You AND it with 1 and take the output. If the output is 1, then what is it? It is odd. If output is 0, then it is even. Try out that question to find whether the digit is odd or even. It is easy. Just AND it with 1. The next questions which you can do is you can find whether a digit is a power of 2 using bitwise operators. So just try out that question whether to find whether a number is a power of 2, and also try out this question whether to find the decimal value of after replacement. That is, you take a position, you replace that position with another bit, and then you find the decimal value of that particular number. Okay, so that is another question, and to find whether it is a power of 2. How do you find if it is a power of 2? 2 raised to 0 is equal to 1. If the number is 1, it is a power of 2. Then the number should be either 2, 4, like that it should go, right? So from you put a limit, you put a for loop, and inside that you take m from value 1 and you multiply it with 2. Each time you multiply it with you to check if it is equal to that number which you gave. So if it is equal to the number, it is a power of 2, and then you put a flag is equal to 1. If flag is equal to 0, then what happens? It is not a power of 1. Again, if it is not, it is not a power of 2. Okay. So you keep on checking the number. Each time you multiply with 2, you keep on checking the number. You keep on checking the number, and once it is equal, you put the flag as 1. Each time it is not equal, it is mentioned as not a power of 2. Okay, shall I do it for you? Okay, I'll do that question for you. This is quite simple. It's just a basic logic. Initially, the programs you have done, it's just a basic logic. Only thing is that okay, here the method of first I have told you is not using bitwise operator. It's a general logic. So this is a general logic of finding whether it is a power of 2 or not. Now using bitwise operator, how do we find whether it is a power of 2 or not? So what happens is you mention the number n and you store it into a variable a, and you each time you right shift by 1, and you take that a and you AND it with 1, and if that particular bit is 1, you raise the flag, you increment the flag. Okay, if flag is equal to 1, what happens is it is a power of 2. If a flag is equal to 1, it is a power of 2. If flag is greater than 1, it is not the power of 2. How does it become greater than 1? Yeah, here the basic logic is if it should be a power of 2, only one of the bits should have a high. right? Rest all bits should be 0, only then it is a power of 2. So you keep right shifting, and if any one of it is equal to 1 and your flag is incremented 1, if flag is incremented only to f is equal to 1, then it is power of 2. If flag is incremented for more than that one time, that is flag value has got a value 2, 3, 4, like the number of ones in that bit is greater than 1, then it is not a power of 2. Okay, so this is a basic logic. I'll just do the program for you. So it is flag you have, I you have, number you have, then you have two variables a and b. Okay, then you enter the number, then here you enter the number. Okay, then you store that number into another number, another variable, and here I am going to write the logic. So what is the logic is like, for I equal to 0, I less than 32, or whatever limit you want to give, you can give, I plus plus. Okay, okay, so then you go into the loop, and what you do is same thing. This a you have going to right shift it with 1 each time, and you are going to AND it with 1. If b equal to 1, you are going to raise a flag. Flag is equal to f plus 1. Okay, you are entering the, okay, this flag increments only for one time. If in this entire loop, if flag is incremented only one time, then if f equal to 1, then what happens is printf power of 2 if flag is incremented for more than one time, then what happens is printf not power of 2. This is the logic here. So now let's run the program. Power Bitwise. Okay, I am going to enter the number 8. It hasn't come. Let's check the program. Output is not coming. Yeah, here a small mistake that I have done is one thing. Here I had to give n instead of that I gave a initially. I had to scan it into variable n, and also first thing is first position. To get the first position, 0th position, I have to take 0 here. So from I right shift I. Second time I right shift by 1. Okay, in that case here I have to take n. I have to right shift by 1. Then you do it like this. So let me check this one. So it's like 9, not a power of 2. 8, power of 2. 17, not a power of 2. 23, not a power of 2. So this is how it works. So I right shift n with I, and then I store it into a, and a then I AND it with 1. Okay, so here I take I. If it is a 8-bit number, I'm going to take it till 8. If it is 16-bit, I'm going to take it till 16. So like that it is going to work. So this is how the program works to find whether it is a power of 2 or not using bitwise operator. If you are not using bitwise operator, then the normal method you can use. Okay, so this is the end of bitwise operators, and now let's go to the next topic.